Hey everyone. Thanks for coming to listen to a grown man complain about PowerShell. My name's David Schloss. I'm an offensive security lead at Echelon Cyber and Risk. So, what that means is basically I run all of our pen testing, red teaming, anything that emulates a criminal. That's going to be my wheelhouse. You can find my email address here in case you wanna link up with me later, or you can hit me up on LinkedIn. I do post tips and tricks on red teaming periodically on there, so come check me out. I also like to say I'm a self-proclaimed malware dev. Uh, I like to see if I can defeat AVs. Doesn't always happen. And then a little bit about our company, just because we're small. We're a cybersecurity firm. We offer defensive advisory and offensive services. So come check us out if you'd like. So, what is today's goal? Basically, I want you guys to have a healthy dose of paranoia about having PowerShell on your user's workstation. Ever since we kind of moved away from PowerShell as a main attack platform and moved into like C Sharp using things like Sharp or Sharp or other things like that, we've kind of ignored that PowerShell is still a very viable attack path for attackers. And as we'll show in this presentation, things that have been around since like 2015, 2016 still function as well as they did back then. So how are we going to do that? Well, we're first going to go over the allure of PowerShell, like why IT admins love it, why attackers love it, and then we're going to go into bypassing controls. So that it's going to be like signed script execution, AMZ, whitelisting, and some like EDR enumeration alerts. And then we're going to wrap all of that up into malware deployment and how you can protect yourself. So let's start off. So why do admins love it? Well, basically, it's everywhere, right? Its market share is huge. It's on Windows, Linux, Mac. I had it on my Linux machine. I had it on my Mac machine when I had a Mac, right? There wasn't a need to really learn anything new as far as languages go. It's just there, right? It's easy to use and learn. This is actually the first application I learned, even before Python or C. PowerShell's the first thing, and it is super simplistic. There's resources everywhere. And then lastly, it enables more functions around remote administration. When I was an IT admin, it, it would take my task from like a couple hours down to like a couple minutes. It's really a useful tool for admins. But why do attackers love it? Basically, it's everywhere, right? It's on Windows, Linux, Mac. I don't need to learn Impacket to go from Linux to Windows. It already talks natively in that regard. I have it on my Kali Linux machine. Super simplistic. It's easy to use and learn. There's a ton of resources when it comes down to offensive PowerShell usage. Um, as people just like to kind of go out there and show off what they can do with it, and it enables more functions around remote administration. So if you have PowerShell already installed on your Kali Linux machine, you really don't need to learn other tools in order to interact with Windows environments, and you can get your malware, other functions from your Linux to Windows pretty quickly. So really, the attackers here have the advantage, right? I think what a lot of people seem to forget is that scripts can be run entirely from memory. You can just copy and paste it from the internet into a terminal as long as you have terminal access. Uh, though, to caveat that, if you have a really good EDR, you might be able to capture some of that, those malicious scripts in like the temporary files, but they are only temporary. But because of this, signature-based AVs have a really hard time detecting activity that's being done from within a PowerShell shell. Because PowerShell is considered a trusted PID, it's not going to be constantly reading the memory that's being run in there. Just like Python is scriptable C, this is scriptable.net, as we'll get into a little bit later in this. And then everybody just likes to bash on Microsoft. So organic security functions are constantly getting defeated and they're constantly being publicized. And it's wonderful for us attackers and it's kind of annoying for the defenders. And that kind of, sets the stage what we're going to be doing. So we're mostly going to focus today on bypassing organic controls with a little bit of like non-organic controls. And one of those first controls that we're going to talk about is this script signing execution. Now, for the attackers in the room, you guys are all going to kind of groan and be like, oh, really? This guy's going to be talking about script signing execution? For those who don't know, this function is a uh, control that's forth by Microsoft to restrict you executing um, scripts that aren't already signed. In its default policy, which is restricted, you are restricted down to shells that are, or not shells, sorry, scripts that are signed by Microsoft. Um, One thing to caveat, or not caveat, but point out there here is script signing execution is not a security control, but a lot of people tend to use it as a security control. So in this screenshot, we can see that we have a low privilege user trying to get the execution policy, which is set to restricted. And then they're trying to set the execution policy to execution policy bypass, which will allow you to just run whatever script you want. And for most administrators, you'll recognize this. There's an access denied prompt that gets pushed back. So you're not able to change it. The reason why this isn't a security control and Microsoft has said it's not a security control is because it's just very simple to bypass it. Let's say you don't have admin privileges, but you still want to run scripts on a device. All you have to do is actually execute PowerShell.exe tac EP or tac execution policy bypass, and it'll put it into the bypass policy. The reason this happens is when you're doing set execution policy, the command, you're actually trying to set a registry hive within the local machine registry or that hive, which requires admin access. But when you do PowerShell.exe tac EP execution policy bypass, it's only setting it for that instance. It's not going to navigate into another window. So if you do re-execute PowerShell, it's going to go back to the machine default. So hopefully now that you guys know that script signing execution is not a security control, you guys aren't going to use it as a security control moving forward because it is quite common to see that. And this is going to lead us right into the fun stuff, which is AMSI or AMZ or the anti-malware scan interface. This is going to be the bulk of the presentation. We're going to talk a little bit about like methods that have worked in 2015 and they still work today with just very minor modifications. But what AMZ is a known good hook that was developed by Microsoft for defense products to integrate into their systems. And it's integrated into like UX, Windows script hosts, Office macros, PowerShell, VB scripts, you name it. If Microsoft provides it as a function or a scripting language, you're going to see AMZ is integrated into that. And it's really cool because it'll block known malicious scripts and functions. So like the IEX download string command, which is very commonly used by us attackers to import malicious scripts into PowerShell, just completely blocked with AMZ. It also looks out for strings like Mimikatz, Bloodhound, PowerView. I believe it still alerts on Matt Graber's name. Um, you know, if it's malicious, it's gonna try to alert on it. Some of the known integrated antivirus applications that are using this right now are like McAfee, Sophos, Kaspersky, Windows Defender, kind of a duh there. And there is probably more, but this isn't a list that is provided by Microsoft, at least not from what I've seen. So you have to kind of dig through. But there are people who are using this known good hook by Microsoft. But unfortunately, because Microsoft is always trying to do the backwards compatibility thing, there's a very, very easy bypass when it comes down to AMZ, which is just downgrade PowerShell, right? PowerShell 2.0 is installed by default. It would be considered living off the land binary, right? Some things that you lose out when you go down to PowerShell 2.0 is automatic script block logging on suspicious scripts. So if you aren't already setting up script block logging, you're no longer getting any of those alerts for suspicious scripts. The only caveat I would put here is that if you are looking to run PowerShell 2.0, you do need .NET version 2.0. But then a second caveat to that is if you have older software on your network that requires .NET 3.5, then .NET 2.0 is installed because they are bundled together for some reason. So what does that look like? Very simply, it's quite the easiest bypass in the world, and this gets a lot of my clients in the past. The first thing you can see here is we're running PS version table. That's just to show you that we are running version 5.1. And then I'm trying to echo AMSI utils. The reason why I do AMSI utils is because I know it's a known string that AMSI will try to block you using because it doesn't like you calling itself. So we try to echo AMSI utils. It tells us, hey, no, that's not allowed. You know, you're blocked by the antivirus. Then you just run PowerShell.exe tac version 2, and now when you echo AMSI utils, it works, right? Super simple, very easy, still works in 2021. This has been around forever. I don't know why they haven't just removed the binary as a whole. But, you know, if you don't have this disabled on your network, probably a good thing to do that now or soonish. So what happens if you can't run PowerShell version 2? Well, then we need to get into some like AMSI bypassing or like AMSI crashing. So when we are trying to defeat AMSI as attackers, we're always trying to put AMSI into a failed state. The reason being is when AMSI is in a failed state, it doesn't have a like recovery function, so it just continues to stay failed. So if you're able to crash it for that instance, like let's say you have a PowerShell terminal and you crash AMSI, you now have a AMSI-free terminal. If you rerun PowerShell, AMSI will come back. So the function that or the method that we're gonna talk about today is a few, but on this one is gonna be the Matt Graber method, which is using reflection. Back in like 2015, Matt Graber found that it was really, really simple to just call AMSI utils and then get the field of AMSI and it failed and setting that to true. And then that's enough to crash AMSI. It goes, oh yeah, hey, my field says I don't work no more, and it doesn't. Thankfully, Microsoft was really quick on the fix, and they implemented so you couldn't call AMSI utils or AMSI and it failed anymore. The problem is despite Microsoft saying that they check for concatenation before execution with AMSI, it wasn't true. So the line below it, which has the concatenated AMSI utils and AMSI and it failed, that worked up until last year. It no longer works, and this kind of took us down into a dive onto why it no longer works, and we're going to explore that right now. So the first thing we needed to figure out is we need to have our baseline. We needed to look at system management, automation, AMSI utils. Let's see if we can call it. It does block it because we are not trying to concatenate anything or try to obfuscate in any form or fashion. But if we do concatenate AMSI utils, it does print, which means that concatenation still technically works in 2021. And that led us to, okay, so how deep down the rabbit hole do we need to go before AMSI starts blocking us? So the next logical step was to go out one field, right? Let's go and get the AMSI and it failed field. And with concatenation on AMSI and it failed, it does read out. We can see that the name of the field, we can get the location of it, what type of field it is it public, all the information that we possibly need on it. Which means concatenation really isn't the problem here. There's something else going on. And thankfully, shout out to Secure This Shit, who has like a great write-up on what is actually going on. But it turns out that when you are calling an assembly type and then you're getting the field and then you're trying to set the value, AMSI does some regex, sees that, and goes, okay, now let's concatenate this all and see what it's really calling so that they can make sure, you know, you're not calling AMSI utils. Which is cool. That's really a neat fix for them. But my number one rule when defeating PowerShell is when in doubt, encode it out. And the cool thing about that is I like to use hex because base64 is already organically in PowerShell, right? You can call a base64 encoded command from within PowerShell. Hex is not. So in this case, you can just concatenate AMSI utils and format it into hex using like UTF encoding. And once we have our text into hex, we need to turn our hex into text. So you get this sweet little like Dr. Seuss rhyme in it, right? So we need like a one-liner to turn that hex back into text. And that's pretty simple because all we have to do is just split each hex line or each hex section and then convert that back into a character, which we can do with the code below. So when we do our one-liner and we print it out, it prints out AMD utils, and we haven't even defeated AMD at all. So it's not like checking this execution before we go forward, which is really neat. So what we can do with that is we can just replace in our code AMD utils and AMD init failed with this small section of code to turn our hex back into text. And what that looks like is this. So the first thing we're going to do is we're going to call AMD utils, show you that AMD is indeed working. We're being blocked. And then we're going to copy in our hex encoded text. Hit enter, call AMD utils again. And now we can see that AMD utils is being called. We can echo it out, which is showing us that AMD has been defeated. So this method that has been, or that was developed in like 2015 is still functioning to this day, right? With very minimal kind of changing. We haven't had to obfuscate it too much. We really haven't had to do a whole lot. Like I'm not doing a Caesar cipher. I'm not doing any sort of encryption. I'm just changing the way that the code or the text is being interpreted, and now it works. So, us ignoring the problem for so long has allowed us to continuously evolve, or us as attackers to evolve and create like small little changes to code and things that have been working for 5, 6 years still work. So then the next piece here is that we're going to talk about is the Rasa mouth method. The reason why I wanted to bring this method up is because I had mentioned that PowerShell is Scriptable.net. In this case, this is just C# code that's able to be run in PowerShell. Very simplistic, very easy. And what it's doing is it's patching the DLL and it's patching the library AMSI scan buffer. So a really fun function about AMSI is, or a fun fact about AMSI, is that AMSI's functions like to have a static first couple of bytes in all of its functions, which AMSI will go out and check to see if those bytes are still the same. And those first couple bytes are AMSI, right? So it's checking, hey, does the function still start with AMSI? Yeah, it still functions. All right, cool. We're gonna keep going, so it doesn't crash it. So what you can do is actually just like find the address for like AMSI scan buffer, AMSI context, things like that. Just rewrite the first couple of bytes with literally anything that you want, and you'll crash AMSI. It's pretty neat. So this is a pretty obvious kind of attack towards AMSI, right? It's loading the loaded DLL that's within PowerShell, which is kind of a cool idea, and then patching out some bytes, which if we go and look at how that looks, you don't have to do anything fancy with this. This still works. Like I haven't had to change any of the code, minus concatenation. Put that in, hit enter. Now we type AMSI again. Maybe. There we go. And we're able to call it, right? So some things that should be going through your mind at this point as well that's outside of AMSI is like if you can edit loaded DLLs, can you unhook DLLs or rehook clean DLLs? PowerShell is powerful. So it's pretty neat. I like to call this one out because a lot of people think that like, oh yeah, you have to get super complex with it. Like I haven't changed any of the code that I got off of GitHub on this one, and I've used it in the past and it hasn't been caught. It's a pretty easy method for defeating AMSI. So what happens when you can't run the code to bypass AMSI, right? Whether that be PowerShell is not a whitelisted application, or you're operating in restricted language bypass or restricted language mode. You could bypass it by going down to PowerShell version 2.0, or you can do what I like to do, which is build your own PowerShell. Because PowerShell is really just a bunch of DLLs loaded on top of the command prompt, and then they called it PowerShell, right? Kind of obvious when you look at it that way. But it's a very simple way of doing that. You can actually just go to GitHub, go to this MS build shell, download it. I've put this on clients' machines in the past when we've been doing red teams or pen tests, and ultimately, it hasn't been caught by an antivirus because, well, it's not malicious in itself, right? If they start alerting on the functions in there, they will start potentially having false positive with other applications. So in this case, MS Build Shell from this GitHub page is using the msbuild.exe living off the line binary, which is included with .NET version 4.0. So in this case, we have the command prompt open. I'm running PS version table to show you guys that it does not have any sort of PowerShell stuff loaded. Oops. Let's try that again. And then I'm calling msbuild.exe with our msbuildshell.cs project file. So you don't need to have Visual Studio's Code or Visual Studios or any sort of like compilation program. All you need to do is have msbuild.exe, which will build a CS project file. So when we hit enter here, it's going to start building the engine, and then we're presented with this wonderful like bright blue screen. And when we type PS version table, we get the actual response that we're looking for. Now, you'll probably notice some red up here. That's the AMD bypass that it's trying to do. It's the old Matt Graber method without any obfuscation. You can go into the code and edit it if you really want to, so that you can get past AMD and all that jazz, but it's not necessary. Additionally, the only other function that you lose by building your own PowerShell is the ability to tab out commands. But as an attacker, I don't think you really are too worried about that if you're just trying to get PowerShell on the device. So when we exit, we can see that we're back down to a command prompt. So here are some more ways to do it. I don't want to get too deep in the weeds about this because we could go like a whole hour just on building PowerShell itself. But there are projects out there like the PowerShell DLL project, which you can use anything that executes DLLs. Or my personal favorite, which is the sync app publishing server.vbs script, which is included by default as well. I'm not too sure why. But if you put in that like break IWR and then your IP and have a netcat listener, you'll get a PowerShell callback. Super cool. Shout out to iRed team here because they have a lot of great write-ups on how to use some of these like PowerShell DLL project bypasses. Go check them out. So we've talked a lot about the organic controls. We're going to kind of wrap it up here as far as bypassing controls with some EDR detection controls. What I think a lot of people don't seem to realize is that commands like ipconfig, whoami, netstat, netsh, these are all like DOS applications that are in your C Windows System 32 files folder system. EDRs have gotten really smart on how to detect when a system is being enumerated because we as attackers haven't really learned to not just like systematically call ipconfig, whoami, sysinfo, like a ton of these commands all in a short duration, which a human isn't necessarily going to do, right? An IT admin may come in and do a ipconfig or whoami, a netstat, right? But it's not going to run through this whole exhaustive list of like, let me get all of the information here. So the really, really cool thing about PowerShell is that Scriptable.net, which allows us to do really fun things like call environment variables or call the Windows API. So let's say we want to do who am I? Who am I is like this desktop.attack AV low priv. Like, okay, that's cool. Well, we can change that up and just call the environment variables like environment variable user domain and environment variable username. And it kind of has a better like output in my opinion. I like that a little bit more. Or let's say we want to do IP config. So we can use the .NET DNS library and get host address for our local host. And it'll print it out. It's not as pretty, don't get me wrong, but it does function. So we can use PowerShell to actually function kind of like how an installer would enumerate a device. And that's going to get around uh, a little bit lower end EDR products. And this is kind of fun. You can experiment it. You can find different ways of printing out the same exact data. And it's almost like reinventing the wheel, but it does avoid detection. And for us red teamers, avoiding detection is always super important. So that wraps it up for uh, evasion techniques, right? Our bypassing. And we talked all about that just so we could get to this malware deployment. So we can really like sink in that, what do you want to call it? That paranoia, right? PowerShell is really, really nice on being able to execute code because you just take your C# code and turn it into PowerShell. This is exactly why everybody went from PowerShell to C# when all of the defense was looking into PowerShell, thanks to PowerShell Empire and others. But we stopped paying attention, and that allowed for the same old techniques to come back out and still work. So to get basic code execution, you really only need a few things, which is like some allocated memory. You need the ability to copy that memory or your shellcode into the allocated memory, and in the ability to create a thread. Now, if you really want to get into the weeds of things and how you would evade, you would use others, but this is just basic code execution. And then you also need to do some avoidance of AVs. It's not as important, but it is still kind of a requirement. You need a way to be able to reflectively call your DLLs, especially because if you don't reflectively call those DLLs, it will create a temporary DLL on disk. Um, and then, some shellcode obfuscation, which PowerShell makes super simple as well. So as far as like importing and executing your code, it's very, very simple. The very, very top line here, this DLL import, this is taken straight from pinvoke. So this is how you would write it into C#. And then this line below it is actually using Matt Graber's reflective DLL loading method. So almost exactly the same. But in this case, we don't have like an unsigned integer. You only have unsigned integer 32 and unsigned integer 64. And then when you want to go execute that code, it's literally the same. The only difference here is your type name is what you are building with the Matt Graber reflective DLL loading. So you do need to create a type, but it's no different than how you would call it anywhere else. So taking your malware from C# and bringing it into PowerShell is super simple. And then that brings us into the last piece of it, which is shellcode obfuscation, right? PowerShell reads everything in bytecode, or reads bytecode as decimal instead of hex. So I prefer decimal over hex because I just find 000 to 255 so much easier than 000 to 0FF. And when you have this like decimal, you can apply really basic encoding principles to it, like the Caesar cipher, right? I think a principle that is missed a lot by attackers is you don't have to be complex with your obfuscation. You just have to have it custom. So if you use a Caesar cipher, it will work. Like I've run code, like interpreter code on systems just using a Caesar cipher. What a Caesar cipher is taking a byte and pushing it to the right or left, depending on which way you want to go. In this case, we'll push everything 5 to the right. So 000 becomes 005, but that creates a problem with like a integer overflow because you can't go over 256. So 255 would be 260. That's not good. That's not going to work. The nice thing is PowerShell provides you with a really easy operator for modulus. So you can take your number plus or minus your offset and then use modulus, which is the percent sign, of 256. So if we're pushing everything to the right, 005 or 000 becomes 005 and 255 becomes 004. Right? Super simple, super easy to implement. So what does that look like? In this case, I built a interpreter shell in PowerShell script using interpreter reverse HTTPS. We're going to go ahead and run that. And then we're going to go into our AV dev, my machine, which has AV on it. And I talked a lot about copying and pasting things in. This time we're just going to import it. One thing to note here is before we begin, the PowerShell PID is 11496. That's important because we are not going to create like a brand new process. We're just creating a new thread within this process. No, shit. Okay, let's go back. So we're going to look at the PID again. And then we're going to copy in AMZ utils, type it in, show you that AMZ is functioning. And then we're going to copy in our .NET way of importing, right? So I had mentioned that IEX download string gets blocked by AMZ. What's really cool is .NET web request does not. So in this case, before we move on, I'll go through this code real quick. So we're calling the .NET web request. We're going to create a new request towards our malicious host, and we're going to download BSidesDFW. We're going to grab that response, and then we're going to get the stream, and we're going to download that data stream. We're going to read it all the way into the all the way to the end, and we're going to import that into a variable. Once we have that variable, we're going to execute it using IEX. So we're not using IEX download string to instantly execute upon that code. So when we execute it down here, it'll say, hey, print out IEX content. We run IEX content. Now we have the script in here. So when we write invoke BSides, execute that, and then we execute order 66 or offset at 66, it's running. You notice there's nothing being alerted down at the bottom. No antivirus alerts. We come back here, and we have a reverse shell. And we get the UID. We're on the low privilege user, and our PID of 11496. The way with doing it with this way, though, with creating a thread, that when we close this interpreter shell, it will crash PowerShell, just as a caveat. But that's a little concerning, right? Like, it's so simple to execute code on a machine just using PowerShell still. Nothing's really had to change in the last couple of years. We haven't really had to change the way that we've done code execution. Now, you can get even more fancy with it and make it a lot harder for the defenders to go and find your activity, but just this basic code execution still works. So now that you guys are hopefully a little paranoid, what can you do? What do you do about it? I dump everything into these 4 simple steps. The first one is disable PowerShell. I personally don't think that every user needs to have it. You wouldn't give your users Python, so why would you give every user PowerShell? That being said, right, you would, if you need to use it for your administration or you have users that have legitimate reasons to use it, then you need to start looking at like application whitelisting and blacklisting. And if you do that, then you need to really expand your application blacklisting. You need to look at every living off the land binary that are out there. Not everything that Microsoft provides to you is actually safe. I don't know if you guys remember DDE Auto, but that was a complete security flaw. And they just said, oh, it's a feature, it's not a flaw. I would say, definitely increase your security products. Go for AI-based security products. I know I'd mentioned that it is possible to, rehook or unhook DLLs, especially those like kernel 32 or NTDLL. But when you unhook those DLLs, the more advanced AI-based security products are able to determine when a system is being bypassed. And the last thing, it's not necessarily for any of you guys out there, maybe, but Microsoft, you guys definitely need to fix your stuff. There's just too many inherent flaws with these security controls, and ultimately, like a defeat that was built 5 years ago still works today because AMZ doesn't function in the way that it is advertised, and that's kind of concerning. But with that, this is my information again. In case you wanted to download the slides, you can come to our website /bsides and download those slides. Reach out to me anytime on LinkedIn, send me an email. I like talking about just about anything. I'm too extroverted for my own good. So, with that, thank you very much for your time. It was a pleasure. I hope you guys have a good rest of your day. Ask any questions.